All right, there you go.
Thank you. And let's see. All right. Clicking on. Are you able to see the PowerPoint presentation?
Yeah, I can see the PowerPoint. There we go.
Let's go ahead and flip this guy. Okay, well, thank you very much for the introduction. And thank you everyone for taking the time today to kind of, come out to this presentation. I'm really excited to get the opportunity to talk to everyone today about graph databases. I hope today you guys learned something and have a lot of fun going through the SQL code and going through the material here and walk away with some cool experiences and hopefully get to use this in some fun side projects or maybe even use something like this at your work. So before we get started, would you mind just please, it looks like everyone already is, but just mute your microphones. It is a ton of fun playing, Zoom bingo while you're at work and hearing, who takes their, computer or phone to the bathroom while they're not on mute or dogs barking in the background. But for this, since it looks like we have, close to 40 people, if you can just mute your microphone, that would be fantastic. But if you do have a question, please do post it in chat that either you do have a question or feel free to go ahead and just type out your whole question. And when I get to a good stopping point, I'll make sure to read off the question or to let you have a moment to ask your question to the group. And I will do my absolute best to answer it. Also, during the stay home or shelter in place order, we're all lacking a lot of interpersonal interaction. So if you'd like to turn on your camera and see everyone's smiling faces, feel free to. Or if you have a really good Zoom background, show off your best Zoom background, and I'll do my best to not get distracted by any really good ones. And lastly, since we do have so many people, if the video or audio quality degrades at all, and I freeze or all of a sudden the audio drops off, please just use the chat and flag me, and I'll make sure to stop, wait for everything to come back, and then repeat anything that I happen to miss. So who am I? My name is David Fundakowski. My current role is I am a senior data architect at InTouch Group. I've been working with SQL Server for the past 7 or 8 years, and in the last couple of years, I've started to kind of make a transition to a more broad data role and start doing more full stack development, start getting more involved in Python and Jupyter and Azure notebooks, and kind of just starting to experience the whole spectrum of all the really cool data products that are now out there in the Microsoft ecosystem. But the more important information about me is I own 6 different ways of brewing coffee. So for this shelter in place or stay home order, it has been fantastic because I am just highly caffeinated all day long. And the thing I miss most due to all of this stay at home order is all the different food that was available over near the InTouch offices, all the Vietnamese places or Indian or tacos or barbecue. That is hands down the thing that I miss most during this whole shelter in place order. So I cannot wait for this whole thing to get lifted first and foremost so I can get back to just eating tons and tons of takeout food. So on to the actual content of the presentation today. So what are we going to be doing today? Well, we're going to be discussing all the graph database functionality in SQL Server 2017 and later. And along with all the graph database functionality, we're going to be doing quite a few different things. We're going to be creating graph objects. We're going to be reviewing all of the new things that are available now regarding those objects, like all the metadata that's available in SQL Server. We're going to be populating all of those objects with a whole bunch of data, and then we're going to be querying all of that data out using new functions and new syntax using T-SQL. And then as we're going through this, we're going to be discussing some of the limitations of graphs and graph objects. All of the code for today is available on my GitHub, and in just a moment, I'll actually send out a link to my GitHub, and you guys can go and download the SQL script or copy and paste it if you want. But I'm going to try to do as little coding today as possible. And I'm going to try to have all of it available in that SQL script so that when you walk away today, you actually have all the code that we use today, and you don't have to be completely following along with me and live coding this whole time. So if you want to go to github.com/dfundaco, there should just be, I believe, a single public repository where you can go and grab the all the graph code that we're going to be using today. So with that, with mentioning what are we going to be covering today, by the end of this session, hopefully, if I did a good job, you'll be able to leave here being able to create all those different graph objects we created inside of SQL Server. You'll be able to talk about those different structures and what they are and what they do inside of the graph. and then also be able to dive into some of the metadata to really understand what those graph objects are and how they're structured. You'll then be able to, as I mentioned, populate those different graph objects with data, set some relationships between them, and then finally pull out that data in a meaningful way using the new T-SQL functions that are available in these new versions. We are not, unfortunately, going to be covering today any sort of large system or platform migrations to graphs. Discussing using graphs versus not using graphs and just going with a typical relational database system, that's a huge conversation, and it depends on what you're currently doing, what your future state looks like. So we're definitely not going to be going into what does that look like moving your whole system over to a graph, since today's presentation is an introduction to graph functionality and not a real deep dive. And similarly to not doing a migration, we're not going to be going into production level scale, performance tuning. What does it look like when you dump 500 gigabytes of data into an OLTP system and try to use 1,000 concurrent users against it? We're not going to be doing that by any means. This is going to give you an idea of what is a graph, what are the objects, how do I manipulate the data in those graphs, and when is it used, or I guess when is it useful? So to actually get into the subject matter of this presentation, what is a graph and a graph database? Well, a graph is a data structure that consists of two things. It consists of nodes and edges. So nodes are also called vertexes or vertices, but a node is your thing. A node is a thing or an entity or an object. It's a noun. So our node is a thing like a user or a person or a city or a restaurant or a post. It's a thing. And then an edge represents a directed relationship between nodes. So there's a point of distinction here that it's not representing necessarily cardinality like a foreign key does, where it's a one-to-one or a one-to-many relationship. An edge here is a directed relationship. And this picture here is from the Microsoft Docs. You can see it's an arrow. It is going from something to something. So it's a directed relationship. And it's like describing a relationship that a person likes a post. So both a person and a post would be your nodes. And then your edge is the relationship between them, which would be likes. And it's a from to relationship. So that arrow in this picture would go from person to post. It's not bidirectional. It doesn't mean that when there's an edge, it goes both ways. And it wouldn't make sense to say that a post likes a person. So that's why it's not bidirectional like that. So it's something really important to remember as we're going through this is that our nodes are our things, and they're connected by these relationships called edges, but they are directional relationships. And we're absolutely going to be getting into this and seeing how it works in code. But I want to just visually represent what it is so that as we're going through this in code and in T-SQL, you can picture in your mind something more visual. So what are some benefits of using graph tables and graph objects? You can store multiple relationships in a single edge table. So for example, and I'm going to go back real quick to this picture. If we have something like a person and a city, or a person and a restaurant, and a person and a post, and those kinds of things, if you think of a social media platform like Facebook or Instagram or anything, a person can like a ton of different things. A person can like a status, a comment, a picture, a video, a restaurant, any of those things. All of those things can be represented inside of a single relationship or a single edge called likes. You don't have to create a whole bunch of different relationships in order to represent that likes edge between two nodes. All of those things could be stored in a single edge table called likes. It's very easy to query data within a hierarchy here. We can have the same node kind of recursively related to itself through edges, which we'll see a little bit later in the demonstration. It can be easy to scale because, as I just mentioned, you don't have to create a ton of new relationships and objects. You can store all of your different relationships between nodes inside of similar already existing edges, like likes, or something that's located in. And then it's a pretty easy adoption going from nodes to edges because the nodes are just things, but it does take a little bit of a thought to think of how edges are the relations now, instead of more of a traditional cardinality relationship. Now this is more of a, how are these related in a, as I mentioned before, a directed relationship. So the things that we're going to be specifically seeing today is some new things within graph databases in SQL Server 2017 and up. Some things to note are, right off the bat, there is only one graph per database, and we're going to see that when we start creating our objects. There is new syntax for both the creating tables, which we create our nodes and our edges. There is new where syntax when we start writing our selects to start traversing the graphs. There are new columns and new metadata in the underlying sys tables that help us identify different graph attributes. And then there are new functions and new T-SQL functions for interacting with those nodes and those edges and the different graph IDs that are available to us. So that is just a whole bunch of what we're going to be covering today. But the vast majority of what we're going to be covering today is all in SQL Server or in SQL Server Management Studio. So I am going to pull up this inside of our chat. I'm going to send out our, let me pull up our participants list and our chat, and I'll send out the there's chat. So inside of the chat, I just sent to everyone the GitHub link. So if you want to go in and download the zip file or just do a copy paste, you can grab all of this SQL code and follow along. If you do have a SQL Server 2017 or greater version. The one I am using today, I believe, is a 2019 version that is actually inside of a Linux container. So everything that I'm going to be doing today is going to be on SQL Server 2019. So let's go ahead and just jump right into it. So the very first thing we're going to do is we're going to go ahead and just create ourselves a Scratch database to start working in today. So over here, just our plain database. And now we're going to go ahead and create some of these tables that we discussed, some of these node and some of these edge tables. So remember, a node is our things or our entities, or if you want to have a mnemonic, a node is a noun. Those are our things. We're also then going to create an edge table that is that directed relationship between our nodes. So the very first thing we're going to do is we're going to create two node tables because we're going to have two node tables and then a relationship between them. So the first thing we're going to do is create two tables. And you can see that these are very similar to how we create SQL Server tables normally. These are going to have IDs that are automatically incrementing identities, their primary keys. We're going to capture a person's name. This one just has a couple attributes for a post. We're going to foreign key from post to person. And then we're going to identify both of these as node tables. So that is the new create table syntax to make sure that you are creating node tables. So I'm going to create both of these, and then I'm going to define my edge table. So my edge table, remember an edge is that directed relationship between two nodes that describes a from to relationship. What's interesting here is I can go ahead and create a edge table and not include a single column on it whatsoever. So I'm going to go ahead and run this. And now I have two node tables and I have a edge table. Let's go ahead and take a look at the two node tables we just created. So I'm going to scroll back up here, and when we created our node tables, you can see we had an ID and a name. I can see those two columns here. However, SQL Server went ahead and created me a node ID column along with this. Same with our post table. I got a node ID created there, but I didn't define that. That just got automatically created for me by SQL Server when I defined this as a node table. So we're going to come back to this in much more detail in just a moment. But for now, I want to go ahead and I want to populate these graph tables. So for person, I'm only going to go ahead and insert person name because person ID was an identity. So that'll be handled without me actually defining it. And notice that I don't have to actually populate that node ID. So what I'm going to do here is I'm going to go ahead and insert into person, and then I'm going to go ahead and insert into post. And with post, again, I'm just going to do the content, and I'm going to do the posted by. I don't need to do the identity, and I do not need to do the node ID. So I'm going to populate both of these, and now let's take another look at those node tables, now that we have some data inside of them. So now we can see something interesting. We have our person ID that got populated because it was our identity. We have our person name that got populated because we explicitly defined that. But now we have these automatically generated node IDs. And let's take a look at this node ID. We can see that it's a JSON array, and it has a type of node. It tells us what schema this is. It tells us what table this record is inside, and then it gives an ID here. And this ID is an incrementing big int value. And we can see something very similar in the post table. Basically, the only thing different in the post table is that it identifies this as the post table instead of the person table. So this node ID is something that's getting automatically generated by SQL Server as we're inserting these records in here. And it's kind of similar to this identity here, except it's in a bit of a different structure. So this node ID, as I mentioned, is a JSON entry that contains the details of this object here, as well as an incrementing big int ID. So now that we have a couple tables in here, let's go actually take a look at them. So inside of our Scratch database that I created, and inside of tables, we see there are graph tables here. That's where these objects are now being stored. So notice that I did not create a graph database when we started off. I just created a plain Scratch database, created some graph tables, and they automatically just get stored inside of this graph tables folder underneath our Scratch database. So let's go ahead and take a look at person and look at columns, and we see something interesting here. So I have my person ID and my person name as expected because those were defined when I created them. And I also have this node ID, which we saw got automatically created by SQL Server. And then lastly is I have this graph ID. And this graph ID, we're not really 100% sure what that is yet, but we're going to get into that in just a moment. So by only defining two columns on this table, and by only defining two columns, SQL Server automatically created a visible column for us called node ID, but then it created this hidden column called graph ID as well. So let's see what else got created on this table. We expect that a primary key would have gotten created because we defined one on our person ID. The other thing that's interesting here is inside of indexes. We expected there to be an index, again, due to the primary key and making it a clustered index. But then we also got this automatically created graph unique index. If I go ahead and script this out, I can see that this creates a unique non-clustered index for me on that node ID. So again, by only creating a table with two columns, two user-defined columns, and setting it as a node, SQL Server automatically made me two additional columns, a node ID and that hidden graph ID, and went ahead and created a unique non-clustered index for me as well. So a lot of these things are kind of unknown at the moment, but we're absolutely going to get into them right now. So let's take a look at some of the metadata about this table. So this looks like the normal system table for our person table. It's a user table. However, if we go all the way to the right side, there's now some new metadata associated with our tables, and it defines whether it is an edge or a node table now. So we now have this bit flag here that's identifying that this table is a node table. So if I wanted to, I could now just query from the systables underlying system table and find every single one of my node or every single one of my edge tables by using this new Boolean. But let's get back to more of the columns, because why is SQL Server creating these columns for us? So if I go and I look for our person table, I see exactly what we see over here in the Object Explorer. I see a graph ID, a node ID, and then our two user-defined columns. Again, if I go all the way to the right side, I can see that we have a graph ID here, which is this graph ID. But then we also have something interesting here. We have a computed graph ID. So what about this is computed? So if I scroll down here a little bit, I highlight this and I go up here and I turn on my included actual execution plans and I run this. We get our same output before where we have our information inside of this JSON array. But if I go into my execution plan, I go to this first compute scalar operator. I open up my properties. I open up my defined values. I see something really interesting here. This thing is generating us a node ID from parts. So when we see from parts, we maybe think of datetime from parts, where you're generating a datetime value by passing it a whole bunch of things, and then it'll create a datetime for you. That's very similar here, is we are creating a node ID by passing two different values to it. One is we're passing the object ID of the table to it. And the second part is we're passing this graph ID with F43C, we can see over here in the Object Explorer on this table, it's this F43C value here. So this node ID inside of our syscolumns table identified it as a computed value, and we can see now that it's being computed based on the object ID of the table and that graph ID. So that makes sense then that this value is identifying that it's a node, because that's going to be available based on the object ID, because the object ID will have characteristics of the table. So these first values, the type, the schema, and the table, are all being derived from that object ID, and then that graph ID as well. All of those things combined create this node ID. So that's how a node ID is being created for us automatically by SQL Server without us having to populate it. So let's look even further. If we use the logic that a node ID is created from parts, and it's created from both an object ID and a graph ID, logically, we should be able to extract both an object ID or a graph ID from our node ID. So let's do that. Inside of our person table, we have our node IDs. Let's use one of the new T-SQL functions here to extract what is the graph ID from that node ID. And we can confirm that this graph ID on each of these records is this 0, 1, 2, 3, 4 values. It is not the identity we set on the table. It is an automatically incrementing big int value that gets created. And that value, along with the object ID of the table, automatically calculate this node ID on the fly and insert it into the table. So to confirm, to use the same compute scalar function that we saw a moment ago, let's just go ahead and make our own fake node ID. So I could do that by passing it the, again, object ID of the table that this record is located in. And let's go ahead and this time, just make it we'll pass it the integer value of our identity column, and we'll call it our new fake node ID, and create that. So we can see here that SQL Server totally accepts these two valid values, generates a node ID based on those parts, and gives us our new fake value. So I want to take that quick tangent to show you some of these underlying characteristics of these tables, because it is really important to understand when you're creating your user-defined values, you are also getting these system-generated values as well as some other objects, like a unique non-clustered index. So I did want to take some time to make sure that there wasn't just a whole bunch of magic surrounding these values that are getting created. There is actually a reason of why these are getting created and some underlying logic of how they're getting created. And I wish I didn't tell all of you to mute your microphones. I would have loved to hear all the gasps when all of you saw this, because when I saw it, I thought it was pretty cool how you can calculate all that and see all of it under the hood. So now let's take a look at our edge. We just took a look at what our nodes were, and our nodes are our things. And so each of our things that we created gets an automatically created node ID. Our edges are what are connecting to nodes in a directed manner, in a from to manner. So remember, we didn't create a single table, or sorry, a single column on our likes table when we defined it. So when I select all from likes, we see that it has a edge ID. This edge ID is the exact same, it works the exact same way as the node ID on the node tables. It is an automatically computed value. However, inside this like as well, the entire purpose of an edge table is to facilitate the relationship between those two nodes in that directed manner. That's why automatically, without us even having to define it, it gives us a from ID, which is a node ID. It's expecting this to be a node ID, and a to ID, and it's expecting that to be a node ID as well. So that is how this edge table stores that directed relationship from one node to another node. So if you want to, you don't have to calculate or don't have to create a single user-defined column in your edge table. It'll automatically do it for you. So now let's go ahead and define our edge with some relationships. So remember, we're going from one node to another node, and our edge table is expecting those to be node IDs. So in order to populate this table, let's go ahead and just say we're going to select individual node IDs from our person table, where our person is Tom, and that is going to be inserted as our from ID in our likes edge. So we're going to be going from this node ID to this node ID in a directed manner, and it's going to be as a likes relationship. So each of these records is saying Tom likes this post. Dave likes this post. So that is how this edge table is storing these records. So now that we've populated all of these, let's go take a look at what happens inside our edge table. So as I mentioned, our edge table, just like our node tables, has its own unique edge ID. So this is, again, it's telling us the type of the table, the schema, which table it is, and then that information along with a automatically incrementing big int gives us a unique record on this edge table. And then we can see the edge table is storing a from node ID to another node ID. So each of these records here represents a directed relationship between two nodes. So similar to the node tables, let's just go ahead and take a look at some of the metadata. So this part I thought was kind of funny. You don't define a single user-defined column on our edge table, but it automatically generates 8 columns for you, which is kind of ridiculous. But all of them make total sense now that we have reviewed some of the metadata and how the node IDs work on the node tables. This should make plenty of sense to us now. So if we go all the way to the right, we can see that there are quite a few hidden columns. When we do a select star from our edge table, we only have three columns that come back. So we can see there are 1, 2, 3, 4, 5 hidden columns. However, when we look at what are these values actually, just like on our node tables, we have a graph ID and a edge ID. This edge ID, just as our node table, is a computed value based on the graph ID of that row, which is that incrementing big int value, and the object ID of the actual table. That's what's generating this edge ID. And then we can see this grouping of from columns is exactly what we expected when we see a node ID. A node ID is created based on a graph ID and a object ID. That is how we generated that node ID from parts. It was both the object ID and the graph ID. So since this is storing a directed relationship between two nodes, it only makes sense that these values are available inside of this edge table because these two values make this value. These two values of a node make this node value. So without having to create anything, we get all of this underlying metadata, and that is what's creating these relationships and giving meaningful purpose to these relationships inside of our edge tables. So I know I just took quite a while just to dump a bunch of records in there and then show you some underlying tables, but I think this is really helpful to understand this is how these records are being created. These are some of the underlying attributes so that as we're querying information, it makes a little bit more sense of what is inside of these tables. And also to just do one quick look inside of our likes table here, you can see here are all 8 of those columns. And just like a node table, this does create you a unique non-clustered index, but this time it creates it on that edge ID. So again, this, just like in the node tables, the node column is unique. Same in the edge tables, the edge ID column is unique as well. So now that we have some data inside of these tables, let's start playing around with it and let's start querying it. So here's the first piece of new where syntax that we're going to be using to query data out of our graph objects. So we're going to walk through this step by step. I want to query out of our graph now, I want to query who likes what posts. That's what I want to query. So I'm going to select my person ID and my person name. I'm going to select just a literal likes just for visual purposes in our resulting grid. And I'm going to select a post ID and post content. And here is the syntax for querying from graphs now. This is using the old school join syntax where you put all your tables inside of the where clause or inside the from. This is how graph syntax works. You put all of your tables, both node and edges, inside of the from, and then inside of the where clause now, there's this new syntax for match. So this is how we are going to traverse our graph. This is how we're going to go from one node to another node by means of traversing a graph. And you can actually see this kind of in a visual representation inside of T-SQL, where we are saying we are going to go from person using the likes edge, using that relationship in this direction, we're going to go to the post node. So we're going from the person node through the likes edge in this direction of person to post, and we're going to end at this node. So this is our way of relating two nodes together by means of that directed edge relationship. And we can see what the output looks like now. Person ID and this person likes this post. And if we go back up here and just take a look at our records, we can see that, yep, Tom does indeed like post 3. These 4 people all cannot wait to get pizza after this is over, and we can see that all 4 of them have records inside of here. So this is the basic boilerplate syntax for how to query out of graph objects. You are, again, just like that visual representation from the Microsoft Docs, you are going from one node to another node by means of a directed edge relationship. And I think it's pretty cool that you have this kind of visual representation of even using this little arrow here to kind of help give you a sense of perspective of which node you're going from and then going to. Inside of this T-SQL, you can absolutely use aliases for all of your tables. You don't have to type out the whole thing. So this is the exact same query, except we are aliasing person, post, and likes, and then using those aliases inside of match to query the exact same record set. So there's no difference between these 2 queries other than one of them is using aliases and one of them is not using aliases. Since this is a directed relationship, and since SQL Server is allowing you to use this kind of visual hinting here, we could actually do the same thing, but going in, not necessarily reverse, but we're just going to visually do it in reverse. So this is the exact same query, except notice how instead of going from left to right here, we're going from right to left here, but we're still going in the same logical order. We are still going from person to post by means of the likes edge in this same direction. So there's no difference between these queries and the queries I just did above. It is still representing the exact same thing, except just in a visually different way. But logically, we are still going from person to post through likes, just like up here. We're going from person to post through likes. That's the exact same query. And for anyone who's super bugged that you can't do joins, you have to do this kind of old school syntax, as it's called, it really does not work. Join and applies cannot be used inside of the match clause. So you have to dump everything inside of the from and then line all of the logic up inside of that match clause. The other thing is you cannot use ors and nots. So I cannot use my match logic and say where this match logic occurs or where this match logic occurs. You can't do that. You can use and, but you cannot use ors or nots. So let's add some more entries into our edge table for another likes relationship. So remember, I said one of the benefits of using graph objects that's really nice is you can store multiple kinds of node data inside of the same edge relation table as long as it abides by the same kind of directed relationship, right? A person can like a photo, a person can like a video, a person can like another person, and a person can like another post. All of those things, the relationship between all of those different nodes is likes. So there's no real reason to make another edge if you don't need to, because you're still representing their same relationship between those nodes. So previously, where I said this person is going to like this post, now I am saying that this person likes this person, and then this person likes this person. Inside of the syntax here, I'm not even listing out the from and the to ID because those are the only 2 columns that are available for me to insert into. So I can just run this query. And now, if we take another look at our likes table, we can see that since our node IDs and our edge IDs are just JSON objects, inside, I think it's SQL Server 2016 and forward, you can use JSON. You can modify JSON values, you can query from JSON values and get all the attributes out. So what I'm doing is I'm saying here, just return me the JSON value from this column and return me the table. And when I run this, I can see here are my first records that I inserted into this edge that are going from person to post. And inside of this table, totally fine, I'm now having the same likes relationship. However, this time it's between a person and another person. So you do not have to create another table that's storing this relationship. It all can go inside of the likes relationship as long as it is just within these two columns, within this one from node to this other to node. But when we think about this now, how do we prevent bad relationships? If this thing is just a dumping ground for every likes relationship, what's to stop someone from putting in something that says that this post likes this person? That wouldn't make any sense. So we can now add constraints, or what are called edge constraints. So I can modify my edge table, my likes table, and add a edge constraint that is going to define the connections that are allowed. And I'm going to say that I'm allowing a person node to a post node. That makes sense for a likes relationship. And a person to another person. That makes sense for a likes relationship. So those are the only two relationships that I'm actually going to allow to occur inside of this likes edge. So now what happens if I try to go insert and say that this post likes this person? If I try to go ahead and run this, this will now violate my edge constraint. And my edge constraint says I only allow person-to-person node relationships, or I only allow person-to-post relationships. You can't have anything else in there. So if someone does try to dump bad data in there, this will fail and say you're violating that constraint. And just like the tables before, just like both the edges and the node tables, I can go and view these in the underlying systables, and I can find what are all of my edge constraints that are available. I can join from edge constraints to the edge constraint clauses, and inside of those, I can see my from object IDs to my object IDs. So I can tell what table it's going from to what table it's going from. And we can see here the object IDs are the same because we're going from the person node back to the person node through this edge relationship. So again, that's kind of some of the boilerplate graph functionality. But here's where it starts getting kind of cool. Here's where we start getting into more of the big graph functionality where you can start hopping multiple times and start seeing these very cool relationships. So what happens if we wanted to hop the graph multiple times? Well, we can start making much longer relationships like this. So let's go ahead and walk through what this one is doing here. I want to select the person name from my person table, but the match, the graph traversal, if you think of that visual representation of what a graph looks like and the nodes and the edges, we're going to do multiple hops here. So we are going to go from our person table back to the person table through the likes table. However, we're then going to jump a second time from the person table through the likes edge back to that person node again. So what does this really mean when we are looking at this, kind of thinking about this? How does that work? Well, if you think about this, this is doing a friend of a friend query. I am trying to find where the first person in the chain is Tom. I want to return the third person in the chain. So I'm going to go from Tom and find who does Tom like. And then I'm going to say, the people that Tom likes, who do they like? So this is the friend of a friend double hop as we're traversing our graph. So here is the records that we inserted into our person likes person sample from above. So if we look again at P1 here, and we see that Tom is our first node that we're going to be doing, we go from Tom to Bill. So this is the first hop here. This is P1. This is our person table connecting back to our person table through our likes edge. So we're going from Tom to Bill. Our second hop is then going to go from Bill to whoever Bill likes. So again, remember, friend of a friend here because it's hopping twice. So I go from Tom to Bill, and I go from Bill to Susie. The next thing that I do is I see that down here, Tom's here again. So I'm going from Tom to Susie, and then who does Susie like? It goes from Susie to Dave. So again, from the person table back to itself, and then whoever it landed on, traverse who they like now. So if we're using Tom as our first person, going from Tom to Bill, and then going from Bill to Susie, I would expect Susie to come back. And then going from Tom to Susie and Susie to Dave, I would expect Dave to come back. So now we are starting to get into some more further away relationships from people based on being able to do multiple hops across the graph. So here is where it gets very, very, very cool. And here is where we can start seeing some really powerful underlying logic. So I'm not going to go through each line in this query because it has quite a few things going on, but this is where you need SQL Server 2019 because this is new functionality called shortest path. So what this is doing is this is going to leverage doing a string aggregate. I think string ag is available starting in 2017 and later. This is going to first return us a person that we're going to start with. So in this case, we're going to start with Bill. It's going to return us a string ag, and a string ag just takes a series of rows and pivots them sideways and more or less just denormalizes them. So it'll put them into a list, a delimited list with this in between each record. So this is going to give us a visual representation of our likes path. The last value here is going to return whichever the last node is during that recursion that it's doing. We are including our syntax that we're using for graph queries now, which is putting all the tables inside of the from query, or sorry, inside the from statement. We're still using our match where clause, but this time we are saying, find me the shortest path between person 1 and person 2. And this just means recurse until you find the shortest path. Again, we're going to start with Bill. We're going to end with Tom. And if I go ahead and I run this, I can now visually see the entire path between those two people. And this is just causing it to recurse until the shortest path is found between those two nodes, between those two specific records in those nodes. So I can go, and again, I'll scroll up just a little bit here. We're going from Bill to Susie. We're going from Susie to Dave. We're going from Dave to Tom. So I can tell it where to start, I can tell it where to end, and I can tell it by what means to traverse the graph. And this query will go ahead and just recurse for me until it matches those conditions, and then return me a visual representation of what those hops were. And if I want to, I can just go ahead and take off this last node. And from what I can tell from playing around with this, is this shortest path will recurse until it gets back to itself, basically. Because if it gets back to itself and then it keeps going again, that's just kind of an infinite recursion. So I believe what it's doing is it's doing shortest path is it's going to recurse all the way until it hits itself again and then terminate, because otherwise you're just going to be stuck constantly recursing. So you can use this query, this boilerplate query here, and even put this into a store procedure if you want, that just says, how do I find the fastest, or sorry, the shortest path, the shortest amount of hops and relationships between this first node and this second node by means of this node. So this is something that's extremely, extremely powerful now in SQL Server 2019. Unfortunately, I do not believe it's available in SQL Server 2017. What we can do also is we can just use a different aggregate function. If my main goal is I want to just find how many hops are occurring, I can just use a count instead and say how many hops are occurring between Bill and Tom. I can find out they're 3 degrees of separation away. If I wanted to here, what I could do is I could start limiting the amount of hops here and say, I only want to find everything that is only 2 degrees of separation away from something. And I can either handle that either by doing a halving, or I can even handle that at the shortest path, because what this here is doing is this is telling it to just recurse basically 1 or more times until termination. I can also give this a restriction and say only recurse X amount of times and find me everything that is 2 degrees of separation away. Find me everything that is 10 degrees of separation away, whatever I wanted to. So this shortest path functionality is something extremely, extremely cool in graph database functionality. So let's kind of scale this out a little bit, right? The whole point of being able to use these graph tables is that you can scale it pretty easily and start seeing some pretty cool relationships between things. So what we're going to do is we're going to start off by just making a couple more node tables. So the first thing we're going to make is we're going to make a city table. We're just going to add a couple of user-defined attributes here, like city ID and city name. We're going to make a pizza place with just an ID and a name. No problem, nothing crazy here. They're both defined as node tables, which is really important. You have to have that as a node table because that will generate that node ID column for you. And the next thing we're going to do is we're going to create something called a located in edge. So a located in edge, we can think there's going to be quite a few different types of relationships there, right? We can have a person located in a city. We could have a pizza place located in a city. So we can store multiple kinds of relationships inside of that located in. This time, instead of just creating it flat out as just an edge table with no columns and creating it, I'm actually going to go ahead and create a user-defined column and put a auditing column on there and go ahead and just default it to the current server time whenever I create a record in there. And I'm going to go ahead and just create my edge constraint right up front during my declaration of this table. Go ahead and create that. And now let's just create some records into our node tables. Our node tables aren't doing anything crazy because again, the node ID is going to be generated for us. The ID is going to be automatically created as an identity. And the only thing we really need to do here is just create the city name and the pizza place. I'll go ahead and populate both of those tables. The next thing we need to do now is we need to alter our likes edge again, because what we now have is we have something else that we can store in this table. Previously, we were only storing person to post and person to person. However, now I want to be able to store in here if a person likes a pizza place or if a person likes a city. So we went from having just only a person liking a post in this table to now we're going to be having 4 different kinds of likes relationships in this edge. So I'm going to go ahead and do a drop and add to modify that constraint. And now I'm just going to insert a whole bunch of data into these tables. Previously, I was saying select node IDs where a certain user-defined attribute was something. So it was someone's name or a post ID. But you can use the JSON value as well to pull out the node ID and say, I want to query records where the node ID is 0. And since that is a unique column, because remember, we created a automatically, SQL Server created a automatic non-clustered unique index on that table. This is a cleaner way to make sure you are actually querying back a single unique record, as opposed to using potentially one of your user-defined ones, like previously I was using a person's name. There could be multiple Toms. So this way, it allows me to get the actual unique value from that table. So I'm going to store all of these. I'm going to store that this pizza place is located in this city. I'm going to store that this person is located in this city. I'm going to store that this person likes this city. And I'm going to store that this person likes this pizza place. So all of these kinds of relationships now can absolutely cleanly be stored inside of our edge tables. So now let's go back and start traversing our graph again and see what kinds of things we can see now. So here, what is happening? I am going to traverse the graph and go, which person likes which pizza place? And then that pizza place is located in a certain city. So I'm doing multiple hops here across multiple nodes through 2 different edges. I'm going from the person node and saying, go through the likes edge and tell me what person likes what pizza place, and then tell me that pizza place is located in what city. So if I go ahead and run this without any restrictions, I can see that Tom likes Emo's Pizza, which is located in St. Louis, and Sally likes Modern A Pizza, which is located in New Haven. So if I wanted to, I can just restrict it and add another clause into the where and just say, I only want to find all the people that like pizza places that are located in St. Louis. And then something that's just really hard to kind of wrap your head around at first is we can traverse the graph in multiple directions. So instead of just doing kind of sequential double hops, what we're going to be doing is we are going to be saying here, I want to find the people that like that city, and then I want to find the pizza places that are located in that city. And we can see graphically, we're going from from person to city from the likes edge, one direction, and then we're coming from another direction and saying, find me the pizza places that are located in that city. So this is saying that this person likes this city, and also this pizza place is located in this city. So for a big, social media platform or something like that, you can start gleaning relationships between different nodes based on their edges or based on their relationships. So I know that Sally likes St. Louis. So if I was Emos, I could say, great, I want to start sending Sally some Emos gift cards or some Emos coupons, because next time she's in St. Louis, I can get her to come to my pizza place. So we can traverse our graph through different directions from different nodes, and also using different edges or different relationships. So this kind of side-to-side one is functionally the same as using an and with a second match clause. Because remember, we cannot use or not, but we can use ands. So this one functionally is, whenever we're doing a double hop in any of these previous queries, is functionally the same as doing an and. So this is functionally the same as saying match where the person likes the city and where that pizza place is located in that city. So this is functionally the same thing. And again, as I mentioned, all of this stuff could just be wrapped in a store procedure if we wanted to. So we can go back up to this query here and say at name2. Let's just go ahead and say at name2. This is at name1. I can say create procedure. And now I can just go ahead and run these as, I think it was starting at Bill, starting at Tom, and go ahead and run these. So all this code that we were using can all be wrapped inside of store procedures or inside of functions. So that is the end of all of the T-SQL. So if you want to review any of this, all of this is absolutely available on my GitHub that I sent out earlier. And everything that's in here now, we can fully script out. If you want to save this or use this, you can go here, go ahead and generate your scripts. Go to next, say that you want to script out all of these tables. You want to save them to a Azure notebook now inside of Azure Data Studio. Pull out your schema and your data. Script out everything. Open it up, and now if you need to, you can send a colleague or a friend or whoever a Azure notebook with all of these setup scripts. And so everything will be set up exactly the same. The Azure notebooks now identify that these are indeed edge tables. It will allow you to insert all of the records exactly as they were, with all of the matching node IDs, matching edge IDs, so all those big ints are the same, and you can now script all of this stuff totally out. It's all fully compatible with SQL Server Management Studio. So the last couple things are, as we discussed some of the limitations throughout the course of this, you only use directed edges inside of those match clauses. So you have to go from a node to another node. You can only have one graph per database. So as I showed, we created just a Scratch database. We didn't create a graph database. All the tables we made that were on the DBO schema, they just got put into that folder within that singular database. You cannot use or nots inside of those matches, but you can use and. Nodes and edge tables cannot be used as temp tables, and I'm pretty sure they can't be used as temporal tables either. And you cannot actually update those $ tables or $ values, those node IDs and those edge IDs. You can't update those. You'd have to go ahead and delete new and delete old and insert new ones. And you cannot actually do cross database queries. So you cannot do graph queries from one database and bring them over to another one. And so that's the end of the presentation and the end of the samples for today. So again, thank you all very, very much for joining today. I hope you guys learned a ton today. I hope you guys have some fun things to go back and play around with. The link I sent out earlier to my GitHub, inside of the README file there's actually a link to a Google form for some feedback. Just 3 questions. It's how did I do as a presenter? How do you rate the subject material? And then just any free-form comments. I'd love to have any sort of feedback. I'm always looking to improve. If you'd like to connect with me, feel free to reach out on LinkedIn or shoot me an email or connect with me on Twitter. And it looks like we have maybe a couple questions inside of the chat. So Dan, did you want to mention anything, or do you want to just go ahead and jump straight into questions?
Well, we can definitely jump into questions, but real quick, before we do that, so we can, people want to get out of here. How about, I'm just going to go ahead and I'll just generate a random number between 1 and 53, which is how many people we currently have here. I have number 50 is who came up. So it looks like Tish Fisher. If you can go ahead and message me, we'll get your information. And you would have gotten the door prize for the raffle that we would have had today. So please just go ahead and message Dan Manley, and I'll get that out. We'll get that information over to you. I don't know if anybody else has. I can definitely see other people have some questions, but man, I could definitely hear myself and saying wow a lot. Like, the functionality is really powerful. So I'm really glad that you showed it and in such a great form. I'm going to go ahead and stop the recording here, but we will continue with questions.